Good morning and welcome back. This video is going to steer you through Test Yourself page 438 and also that's page 438 questions 1 to 8. And then what I want you to do is you answer these questions on an A4 page to GCSE standard. You upload them to me and I mark them. Again, this whole exercise is time bound, so if you put it up late, you put it up late. But remember, I'm storing all these as evidence of your work. So let's look at chapter 36. I'm doing questions 1 to 8, and this is your scaffolding page that'll take you through this, and you should be able to do this quite handy. So I'll read the questions and we'll discuss them as we go down through, and then you do them with us and stop the video, or you can look at the whole video and then do them all. But I want high quality work. State the size of the angle of incidence when the incident ray strikes a plane mirror at 90 degrees. So let's just draw this. So I'm going to draw the plane mirror. There it is, and there's the moustache at the back. And I'm going to draw a normal. Now again, I have a ruler, look, you hear it. There's the ruler, I'm going to draw a normal. So being high tech, I'm going to do it, it's a green one. And a normal is an imaginary line at right angles, and there's it there. That's a very imaginary line because it's not there. There you are. Little frog in the throat. And there's the right angle. See with the blue spot? I'll just move the blue spot. So there's your normal, an imaginary line drawn at right angles. And now we're going to put the angle of incidence. State the angle of incidence when the incident ray strikes the plane mirror at 90. So I'm going to use a blue line, and and there it comes in right alongside it. So it's going to come in there. There's the blue line coming in, and it's going to bounce straight back out. So what's the angle there? The angle is very simply 0 degrees. There is no angle between them. Fair enough? I'll stop eating those frogs. The angle between the plane mirror and the incident ray is 40 degrees. What size is the angle of refraction? So let's draw this one. Again, I'm going to draw the mirror. There's my mirror. This is question number 2. I better label it, but then you know where you are, and so do I. So I'm going to draw a normal. I'm using a ruler. There's the normal. Just draw it black. There's at right angles. So I'm going to draw an array of light. Now let's read the question. The angle between the plane mirror. Right. So always be careful. I've told you. The examiner. There's the red one coming in. And the examiner tells me that's 40. But he's telling me a lie, because the angle of incidence is measured from the normal. Look at the blue arc there, see it? So it's going to bounce off at 40 degrees. So there it is. Put the arrows to show it coming in and going out. So I'll change the colour of my pen. That's 50 degrees, because 50 and 40 gives me 90, the right angle, the normal. So the angle of reflection, so it's going to bounce off, is also 50 degrees. So the answer is 50 degrees. Fair enough? Right, the angle between the incident ray and the reflected ray is 130. So let's draw an eye diagram. It's question number 3. So we're going to draw an eye diagram. I've got to put the hairy bit on the back of that. Fair enough? I'm going to draw another plane mirror. There's the plane mirror. I'm going to draw a normal to it. Hopefully it changed the colour of the pen. There's the right angle. Fair enough, there's your normal. And now we're going to draw the ray coming in. Right, I have measured this. How do I know? Listen. What does that sound like? A protractor. What's this sound like? A pencil. You use both. So in comes the ray like that. The arrow shows it coming in, and I measure that angle is going to be the same as the angle that comes out. So I measure it carefully with my protractor and draw it coming out, like so. And that, it tells me in the question that that angle there is 135. Now 130. I thought maybe somebody was a Massey Ferguson figure there and that was 135. So that whole angle is 130. Do you see that? It's the whole, look at the blue line. The whole angle is 130. So that angle is 65 and that angle is 65. So the answer is 65 degrees. Fair enough? Now the next one. Write the word ambulance in its laterally inverted form. Now laterally inverted means right becomes left and left becomes right. So if you're left-handed, I think this could be actually a bit handier, but maybe that's just me being crooked again. There's question 4 done. And that's what you would see in the rear view mirror of the car if you were driving. Fair enough? Ambulance. Get out of the road is what more or less they're telling you. And that would be the right thing to do. So let's look at question number 5. Question number 5. It says 2 plane mirrors are inclined at right angles to each other. A ray of light strikes one mirror M1 at an angle of 30 degrees to the incident, and the reflected ray from M1 falls incident on mirror 2. Find the angle of reflection at mirror 2. Right, so let's draw it for a start. So I'm going to draw the 2 mirrors, and they're right angles. I'm using the protractor. Look, listen, and there's my pencil. You have to use them or you don't get the mark. Don't try submitting them into me with not the right angles on it. Now there's the 2 mirrors at right angles. Now I'm going to draw a normal. And there's the normal. Right? Now I'm going to draw my ray coming in. Here comes the ray, and I have measured this at 30 degrees. Happy days. And there's it coming in. And that's going to be reflected off at 30 degrees. Angle of incident is equal to angle of reflection. Bounce off. There it comes off. Oh, it would if I could draw it. Do it again. There you are. Take it from me, in my world that's a straight line. And then we're going to have to work out this. So I'm going to go to the black pen. That angle's 30. And that angle's 30. So that angle's 60, because 60 and 30 gives me the right angle. There's another right angle there, and that's 60. That angle there is 30. If that one's 30, let's draw a normal then to this. Go to the green. Go to the green. There's my normal. Oh, indeed it's not. There's the normal. Nearly. We're nearly there. There's the normal. Must be an echo in this room. Right, so that's 30. So that angle there, let me change the colour. That angle there is 60. So this angle coming off must be 60. So the ray bounces off at 60. But if I could get the pen to behave itself. There we are. And that's 60. That angle in there is 60. So what's the question asked? Comment on the direction of the ray incident on M1 and the reflected ray. So the angle of incident is 60 and the angle of reflection is 60. Fair enough? There's that question done. Question 5 now. See, when you're submitting that, I want to see a good clear diagram. And I want a pan view taken right from above it that I can measure the angles and give you the marks. And let's do question number 6. Question number 6. It says, a student stands. So must be a bit on the vein side this way. So let's have a look. There's the mirror, and there's the student. Poor matchstick man. So what do we know about the properties of a plane mirror? It's virtual. You can't put a screen and get it. It's as far in front as it is behind. Right becomes left and left becomes right. And not really matter much in this matchstick man because he's sort of symmetrical anyway. It's virtual. Same size. That's the same size as that. It's virtual. It's the same distance. Virtual, same distance. Laterally inverted. And that's about it. Now, for some reason, we're going to call that x. So that distance there is x. And this chap decides to stand back. I'm going to draw him draw in blue, right? So there he is. It doesn't look very clear. Blue made him in the his colour, like. So there is the new man. So he's now 20 back. So the new image, he'll also be 20 back. Yes? So this has moved 20 back, and this will have moved 20 back. So the question is, by how much has the distance between the student and the image increased? Well, that's 20, and that's 20, so it has increased by 40. Fair enough? That's bad news there, that chap's missing a leg. Yeah, I got it back. Fair enough? So there's question number 6. Now question number 7. You might have seen question number 7 in a previous life, for the simple reason I did it the other day, right? So there's no reason for you not being able to do this, but I'm going to do it anyway. There's the mirror. Fair enough. And I'm going to draw on the grid. Can't get that going any finer, but I'll just draw on the grid here. Yeah, I'm getting it there. My life's so excited at the minute doing this stuff. So there's the grid. You could draw the grid. God forbid if you ever went into some graph paper and do it that way. It's not a possibility. So, as you can see, I'm just drawing the grid. Take my time and measure it. You see, this is the whole thing about these rays of light. You just have to be accurate. If you're not accurate, it's wrong. Right. So, there you are. There's my grid. It's very similar to theirs. Right. And now I'm going to put, because I'm high tech, I'm going to use a bit of blue here. There's that one. And there's that one. There's the L. So the image is virtual. It's the same way around. It's laterally inverted, same size. And what's the third? Laterally inverted, same size as object, same distance behind. Right, so we'll make the image a red one. Follow the blue spot on the screen. That's 1 unit away from here. So that one will be 1 unit there, so I'll just put an X there. I would put an X there when you can't see it. No. I'll want to undo that. Undo. Right. There's one. Now, look at this one. Follow the blue spot. 1, 2. 1, 2. So there's one there. And then we'll go to this one. 1, 2, 3, 4. 1, 2, 3, 4. And now I'm going to join those up with my ruler. Yep. So there's it done. It's laterally inverted. The right hand side of this one is now the left hand side of that one. Please blue dot go. The right hand side of this one is the left hand side of that one. The left hand side of this one is the right hand side of that one. Please go across like that. See that? Right? So it's laterally inverted. It's virtual because you put a screen there, you get nothing. It's the same size, look, they're both the same size. And they're the same distance. So that's that one done. So again, see when you're handing this up, I'll expect to see it as clean and tidy and done with pencil. See if it's done with pen, you get nothing. So let's do question number 8. Oh, didn't change colour pen. Oh, what a disaster. Right, question number 8. We did this question before. So I'm going to quickly sketch this. Right. I'm going to use my protractor, listen. I'm going to get my angle of 120. And then I'm going to put the moustache on it to show the mirror. Fair enough. Then I'm going to draw a normal to this point here, because we've done all the normals green so far. We'll still do green. There's it there. And that's at right angles. And we're doing the rays of light red, so we'll do it red. So I'm using the protractor again, and that angle's 65, and it's coming in. Change to black, and that's 65. from the normal, look at the blue arc, doesn't say 65, right, 65 degrees, it does in my world, right, and that red line also strikes there. Let me see, can we get that lighter, right, now it's going to bounce off at 65, so I take my protractor and I measure 65, so measure 65 now, so it's going to bounce off at 65 to the other mirror. There's the arrow to show what way it's going, and I now know that that's also 65 degrees, and I now know that that's 25 degrees, and I know that's 120, so 120 and 25 is 145, and 145 from 180, because that makes that one 35, so that angle in there is 35. Now I'm going to draw a non-normal, and our normals are green, just to show you. You could do this all in one colour pencil, like the one you got for Christmas that you're not going to use. Oh, a bit like that green line. There's it there. Yes, there's the normal. So I know that this ray of light is going to bounce off. Change the colour then at 55 degrees. So I have measured the angle of 55 degrees, and there it is. And I know that that angle is 55 degrees, and I know that that angle is 55 degrees. Now let's answer the question. Calculate the angle of reflection on mirror B. Answer is 55 degrees. Now there's questions 1 to 8 done. And all the stuff that you need to know is on this video. So what I want now, I want the highest standard of work that you can do on A4 pages, upload it to Google Classroom within the time limit that I give so that I can mark it. Fair enough? Thanks for listening. I'll talk to you shortly. Toodle bit.